Jai Hind to all, and today's topic is in the networking layer. In networking layer, what is it is basically do into a computer networks. We will see you. So my name is Aarti Chaudhary. I'm assistant professor at AKGEC. So in today's PPT, what we have to do is, we have seen that it is a data link layer as an TCP and IP. TCP or OSI model. We have seen that this is a network layer, which is basically what they do. That is error control, flow control, and all these things are done by this dimension. And this is a transport layer. Transport layer is what the transport handles is to be. The data is coming from the transport layer and going to a network data network layer, and then it is going to a physical layer. So in between there is a network layer. What the basically the work of the network layer, we will see that. So the services that is of multicasting, routing problems, routing. How can we do is, next we have our address resolution, fragmentation. So we basically target this addressing into our this lecture. What is addressing, what is the address space of it, what are the notations we are using into it, what are the addressing, that is a classful addressing, classless addressing, which we used to do into a IP. So we are having two versions of IP we are using. Basically we are using a version 4 and version 6. But basically that is to be done in a version 4. So what are the duties of the network layer? Inter-networking, what we have to do is, this layer is have to deliver a network from the source to destination. That we need an IP address into it. That IP address, we will see that what IP address for, what are the notations of we will see that. Addressing we have to do into two classes, that is a classless and we have a classful. Okay, routing, how static routing we will do a dynamic routing into it. How can we form the packet into it? How we do the fragmentations of it by using a sequence number of it? How can we do it? How can we control the congestion into it? So all these duties has to be handled by the network layer. But we will basically in this lecture we will focus on what is the addressing we are using into a network layer. Okay, so we are just going for mention. Basically IP address will be used. So IP address will be having two versions. We will use, currently it is using a version 4. This is V4, that is a version 4 we are using. So in version 4 we are having a 32-bit long. 32-bit long, that is to be the version 4. So this is a 32-bit long and it is uniquely and universally defined. So no two computers have the same IP address. So when we are going for a OSI model in which there is a transport layer, this is a network layer, we are having a data link layer, and this is a physical layer we are having. In a network layer, that is done port number. We have a port number in which process to process delivery is to be done. In the network, it will have a IP address, that is a logical address we are used to here. In the data link layer, that is a MAC address, that is a physical address, and in the physical layer we are having a wired or unwired media, what we are having in this. So in this we are having a IP address, that is also known as the logical address also. In this we have to define that uniquely and universally defined. It is a connection between a connection of a devices, and it is of any router, in any computer. Everyone have a IP address. If you are working into a network, into a networks interconnected of computers, then you have to make sure that these computers has to be assigned an IP address. So in that session, what we have to discuss is this the address space. What are the notation we are using into our IP address when we are going for that IP address. Two types of address we are focusing on, that is classful and classless. Okay, so we will go for one by one. what is the address space of that? So in the IP version 4, that is of 32-bit long, that is of 32-bit. So we are having a 32-bit long IP address. We are also having a version 6 IP address. If we are having lots of computers adding to a network, and then after we are not having so much IPs assigned, so we will increase that, we will make that we will version 4, version 6 will be used, and in that we have to convert that version 4 to version 6, and it will be subordinately increase the IP address space is also increasing, and it will increase the number of the computers which will be we used to add into a network. So when we are having a need of it in a future, when we are get to know that these computers, these so much computers are doing, and the population is also increasing, so we will use in a future the version 6. But currently we are using a version 4 here. That is of 32 bits, 32-bit long we are having. So it will uniquely and universally. No two computers have the same IP address, no two routers, no computers. Everyone in the world has not having a same IP address. If you have purchased an IP address that is static to you, for example, we are saying that Google have an IP address. So that IP is fixed because that is purchased by Google. Yahoo server we are having. But all these, we are having an IP address, we are not having a temporary, that is on temporary basis. When we connect it to a computer, we are getting a temporary IP address, we are using it, and then after we are not with it. Because for the permanent IP address, you have to buy it from the DNS. So that has to be there. But when we are using a static, so we have to purchase it, and it is universally that is assigned to you, or nobody will able to change it. That is Google servers, Yahoo servers, all these have a purchase an IP address of version 4 here. So when we are saying that what is the address space of IP version 4, so what we are saying that it is of how much long is 32. So how much we are knowing that we are using 1 zeros and 1 heres. The one when we are saying zeros on how much combination we will say is 2 raised to power 32 combinations will be mentioned. 2 raised to power 32 matlab 2 is all because we are using a binary system. You are using zeros and 1, and then after zeros 1, how much combination you will get to into 2 raised to power 32. That how much we are long is this much long we are having that. So this much host, computers, servers, routers will possible into our IP version 4. If this limit exceeds, we will go for a version 6. That is into a theoretical concept, but now it will make it a practical by making that conversion transfer of the version 4 to version 6. Okay, so this much is a limit of using a version 4 here. So this is a representation of IP version 4 address, in which we are having a this dotted representation of decimal, or also we are having, so we are having 1, 2, 3 and 4. We are having 4 we are having that. So in that we are having a 8-bit. So we are saying that this is representation of 8-bit long. This is a representation of 8-bit long. This is a representation 8. So 8, 8, 8 and 8. How much? 32. We will get a 32. So we are saying that 888 octet you will have. In octet, you will go for 0 zeros to n. So it will go for up 0, 0, 0, 5, 6, 7, 8 to how much? 1, 1, 1, 1, 1, 1, 1, 1. So this is a mention. So you will go from, every octet will go from zeros to 255. So any IP that is coming into zeros to 255 is valid IP. So every octet will have a value up to 255. So in this also it is 255 up to 255 up to 255 octet. So it will the decimal value goes from 0 to 255. Other than 256, 277 is not a valid IP in a version 4. So every octet is represented by a 8-bit long. this 8, this 8, this 8 and this 8 is combined to a 32-bit long IP version 4. So how can we have represented it? You can do it by, this is 0, 1, 2, 3, 4, 5, 6 and 7. What is 2 raised to power 7 is? 128. This is 0, 1, 2. This is simple conversion of binary to a decimal. How can we convert it? We will write it all the subscript by 0 to 7, all because 0 to 7 8-bit long. So 0 to 7 is a combination, and then after your what will have to 3, 4, 5, 6, 7. So that is 2 raised to power. What is it? It's the combination 2 raised to power 0 into 1 plus 2 raised to power 1 into 1 plus all zeros and 2 raised to power 3 into 1. All zeros it multiply by 0, that is also 0. So we will count only the ones. All zeros will be cut down from here. So 2 raised to power 3 is 8 plus 2 plus 1, that is resulting to 11, and this is in mind this. So we are simply converting all the octet into a what is that is defined into a what? That is a binary one, and binary you have to convert it into a decimal by using a subscript here. So that is 0 to 7 that we are limit to it. Okay. Next is a binary representation. This is a dotted decimal representation, and this is a binary representation of it. What the IP version 4 we are having. So these are the question we will see that. So change the following IP address from the binary to dotted. So what we have to do is we will make it this 0, 1, 2, 3, 4, 5, 6, 7. Okay, and so with this is also 2, 1, 2, 3. We are not making 0 to 1 that all long is 32. No. Every octet will start from 0 to 7. So this is 4, 5, 6, 7. This is also 0, 1, 2, 3, 4, 5, 6, 7. This is also 0, 1, 2, 3, 4, 5, 6, 7. So we are converting this binary into a decimal. This is what is it? We are replacing 8-bit into an equivalent of decimal and add dot into it. So this is a separation of dot. This is a separation of dot. Here is the separation of dot. So what will we are having is 2 raised to power 7 into 1 plus 2 raised to power 1 into 0, that is 1. So that is 128 plus 1, that is 129. So this representation of 11, the same representation of 11, this is mentioned, but it will not exceed 255 because maximum all ones we will go for a 255. That is defined. All zeros, 0. So 0 say 255 tak it will reach out, but other than that it will not. Same with this case also. Okay, so this is a simple question to convert a binary notation to a dotted decimal notation. Same vice versa also. We have to contain our total decimals into a binary. How can we convert it? So we are having a what? 1, 1, 1. We will divide it by 2. So we will convert into a decimal into binary. What will happen is we are having 5. This is 1 and this is 555. 1, 2, 2. This is 7. We will having a 114. We will having a 1, 2, 1, and we will having a 3, 1, 2. We will divide it by just 6, 1, 2, 3, 0, 2, 1, and 1. So we will write it by this. So this is 1, 1, 0, 1, 1, 1, 1, 1, 2, 3, 4, 4 ones, and with 0 with we have to make it 7, and but the octet is to be 8. So we have to write it 1 0 extra on the which side is to be left hand side. So that is the 0 1 1. So 0 1 1 0 1 1. This is a representative. We have to divide every octet by 2, and then after we will represent that. Okay, so this is a representation of this and this is a representation of this. Okay, so we will see that. Next, the next question will arise on this. This is IP address. Is this a IP address or not? Valid IP address. So we will see that in the first one. Okay, first octet is 111. Okay, 0 to 255, it's okay. Okay, but if we have to write 0, 45, so that is 45, we will not write 055 or 0045 or 0. We will not write extra zeros because it will increase our octet into it. But we are having a single octet from 0 to 7 we are having. But if we are we have to represent this also. So we will not write, so no leading zeros into a 45 we will have. Next, what we have is this 211, 2, 3. So we are having 1, 2, 3, 4, 5 octet. No, we are having not more than 4 octet because we are having a limit of IP version 4 of 32 bits. So this is also not the valid IP address. So and one this. Okay, we are 1, 2, 3, 4. We are a valid 4 IP, and then what happened? It will exceed 255. The 255 will not represent it in 8-bit, so it will exceed the bits, but it is not because that is fixed. 32-bit is fixed for the. So this is not less than 250, less than or equals to 255. That's why it's not a valid IP address. Okay, this is also a IP address. This representation, no mixing. If it's a decimal, it has to be in all decimal. If it is to binary, it has to be on all binary. There is no mixing of it. So mixing is not allowed, has to be. So this is the mention. So then we have to divide. We have go for our notations also. We have go for address space also. The third thing we are having into addressing. The addressing is to be divided into 2 parts. That is a classful and classless. In a classful addressing, we are having a 5 classes of it. A, B, C, D, E. We are dividing our address space into 5 classes, A, B, C, D. That is classful addressing we are having. So in classful addressing, we are having a notation in which we are having a binary notations also, a decimal notation also, in which the first byte is 0. In a binary notation, it is a class A. If in class B 10, in class C that is 110, in class D 1110 and 111. These are fixed. If you are having these things, then you will identify which class it belonging to. This IP will belong to this class, this IP will belong to this class, and this IP will. So all because of this IP in the binary notation or in our decimal notation. If we are saying is 0 to 127, then it is belonging to class A. 128 to 191, it is of class C. 192 to 223 is of class C. 224 to 239 is of class A, and 240 to 255 is of class D we are having. So we are having up to 255 because this is the only combination we will have to do it. So this is a binary notation. This is, we are having first octane, second octane, third octane, fourth octane, because all these are separated by a decimal. That's our dot here. So what we are having is, this is a binary representation notation in which we are having a zeros and one combination. Then we will able to identify in which IP address it is belonging to. But in a decimal notation also, we are having a dotted decimal notation. We are having 0 to 127, 128 to 190. We will able to identify in which class we are having. So this is a quick example of it. We are having a classes, and we have to identify in which class we are. So we will see the first number, that is 0. Okay, is this 0? Then it is of class A. First bit is 0. If it's 110, the 110 in which class? That is in C class. So you have to learn all this. 0 for class A, 10 for class C, 110 for class C. So you have to remember this, and then after you will able to answer these questions of this, in which class it is. Then is 14. The 14 is it in the class A, because we are our decimal notation, it is class A. And this is 252. 252 in which class? Class E. Class we are having it. So there was the thing that if we are using a IP version 4, so what are the possible number of blocks we are having into it? So we are having that how much blocks we are. So if we are having a version 4, so 2 raised to power 8 are the blocks, and how much we are remaining is 2 raised to power 24. That is a combination of it, how much host we will get it. So these are the network we will get it, and these are the host we will get it. In this 2 raised to power 16 we are having 16, that is a number of blocks we will have, and the block size of 2 raised to power 16 here. Here 2 raised to power 24 here. and 2 raised to power 28 here also. So we are having in the B and C class. So we will see that number of blocks is 2 raised to power, that is 2 raised to power 8, and this is 2 raised to power 24, the block size of 24. So this much network we will have in class A, and this much IP will assign to that network. All IP will assign to single network. The block 1 have this much of host, the block 2 is also this much of host. So these are then representing the network, how much network we will have into this, and this is the host which is there. So we will have a like this in real time example. This is a like city we are having. This is a city, and this is how much number of hosts, number of IPs, number of we can say houses we can allocate to it. So this is a city. 128 city will be supported in it, and this much host we will having in that city. This much houses we are having in that city. That is a limit of. And this is also an application of unicast infrastructure. So this is 2 raised to power 16. This is use 16 because 2 bits are there. So that is 2 raised to power 16 minus 2, that is 2 raised to power 14 here. Because we are having used a that is fixed. 0 will not change to 1 here. These 2 bits will not, these are permanent bits. So you will, in 2 raised to power 16, there was 2 bits as fixed. So we will use that only 2 raised to power 14. We will have 16 minus 2, that is 6. And these are mentioned, the minus 3, that is 2 raised to power 21 will be used. So in which we are having a 2 raised to power 24 minus 3 bit is this, 2 raised to power 21, and this is 2 raised to power 8, and this is 2 raised to power 16 here. So these are the number of network, and the host will be there into that classful addressing. So this is a unicast, this is also unicast. These D or D are reserved or multicast. If want to use in a army or defense purpose, we use D and E, but in our daily basis, we use only up to A, B and C. We are using into our daily lives. In a classful addressing, what we are saying that if we are saying that I don't want this much of host into my network, 16 lakhs, 16, this number is 10 lakhs, 16 lakh, how much host I will go for it? If this is not my need, I will only need 2 lakhs. So only that 2 lakhs will be assigned to it, because these are not having 2 lakhs capacity, but this is having a 16 lakhs capacity, but only that 14 lakhs are wasted. So this becomes very tedious to use a classful addressing. So this makes a IP addressing wastage to it. This will arise, or this is the origin of classless addressing into our picture, and that IP version 4 currently using a classless addressing. That's how much IP you will need it, you will assign to it. This is not making that IP address wastage to it. So we are using that IP address to it. So the classful addressing we are using at the lots of IP addresses are wasted. So this will arise to a classless addressing into it. Okay. So we are having a default classful addressing into it. If we are saying that we are in the class A, we will go for A, B and C, because D or E is used for defense and multicasting purposes. We are not using that also. So we are using that, say, in this class C, 8 bits are for network. So, or if I'm making all the 8 bits 1 and others or host, that is version, that is 8. So that is /8. The CIDR is making that /8 if it's class A. If /B, because it's 16 of network, so it will make in 16 for host and 16 for the network. And this is all for 24. This is for the network horn. This is for the host we are making. So all that is network, we are making all that as 1, and all the bits that is of zeros host, that is making this. So what are the subnet default subnet masks? 255.0.0 for the class A. If we assign any IP to any computer or any router, it will giving a default sub ID that if we are belonging to class A, it will make all ones first ones and then after all 24 zeros. If you are go for class B, then what we have all 16 starting with left hand side, all 16 zeros ones, and all right side or 16 zeros, so that is 255 255 00. And then after on the class C, we are making that all the bits right left from the left hand side 24 ones, and then after 0 this is 255 255 255 zeros, and this is class of C. This is our default mask of we are using a classful addressing. But when we are using a classless addressing, the picture will becomes other way. Then we will see that. Then a classful addressing, this is obsolete, and we are using a classless addressing into a current scenario. So what we have to do is, we have to say that this is a scenario. We have to blocks of address in which the block will have a dotted address. I have to making that you will make a 16 address to me, a small address, only 16 address, 16 computers are assigned to it. So you are just making that in this you have to assign the IP address to me. This is a question that I am giving a small organization and having a small business of it, and we have need only a 16 address to it. So how can we do it? So we will have to restriction the block. How can we restrict it? So you have to be there that if I am assigning 1 2 3 4 5 to 16 up to continuous we are appointing. If we are having a 16 to 2 raised to power 4, that is 4, we are only divisible by 16. We are converting that address, first address converting it is to be divisible by 16 and result in this. So this is the first approach to having it. The block of starting with any block will start with 32 and then it will go to 47. This is a 16 bits we are assigning to that convention. But how can we do it? This is a class less addressing. We are having that. So in IP version 4 addressing, a block of address will define to it. We are doing at, we are representing IP addressing into a classless addressing is x.y.z.t/n, that is a in network mask we are giving. This is a IP address and this is a network, that is mask we are giving it. Now we are not giving it 2 raised to power division. We are just making a 27, 28. So this is not a power of division. Only 8, 16, 24 is the power of it. We are not making that right now because we are using a classless addressing. There is no A, B, C, D, E class. There is no that class comes into a picture. So we are having the first address. How can you find our first address? We will find a first address in the block can be found by setting the rightmost 32 minus n bit to a 0. If we have to last address, making it 1. You will see that into question. A block of address of small organization is a address, IP address is given /28. This is my network. If I am giving an IP /28, that is a mask. 28 means all 8 are ones, and then after all zeros we are making that. So that is network is of how much bit? 28. So that is 28 is not any class, so it will not go for class full addressing. It will come into a classless addressing in which 28 bits are the binary. So we are having 8.8.8.8. So all these are 24, and in which this is 24, 25th bit, 26th bit, and 27 bit and 28 bit. All these are ones. So these ones, these are the network. All these are 1, and the 30. Then we will say that this 25, 26, 27, and 28, 29, 30, 31 bits, because we will starting with 0. So these are all ones and these all are zeros. This is a process called subnetting here. And with this subnetting, why we know this subnetting? Because we know that IP is wasting into our host. Because 16 lakhs in our class A we are using, we will use a 16 lakhs. But why we use it? So we are borrowing a bit from host and giving to our network. If we are saying that it decrease the host into a network. Because if we take a bit from a host and then after give it to a network, then we will say that that bit is to be given to our network, and the network will increase, but the host in a network will decrease. We are saying that number of city will increase, but in the city the number of houses will be decreased. So according to your need, how much houses you made it, I will do a subnetting according to it by using a classless addressing here. So what we are having a 28-bit. That 28-bit has to be all ones, that is a network ID, and then after all other zero, that is 32 minus 28. 32 minus 28, that is the all the ones, that is only that 30 with 2, 8 minus, that is 4. That is 28, 29, 30 and 31. All that bit is to be zeros. So what we have to making is all 21. So all that 255, yeah, same 255, same 16, same 27. Then what is this is 39. So all that bit is 28, 25 bit, 26 bit, 27 bit, 28 bit. All these are same as this, but other than all that bits, all that bit has to be all zeros. So what has this to be? If we have to get our first address, what we have to do is, we have a network ID. How much bit is to be network ID? We have that 28 bit. We will not touch all the left side 28 bits. Then after all the 4 bits that is in a host, it will be touched and become at a 0. This is the first address of our block. So this is to be a 32. We will start our block from 32. Okay. Next, the last address what we're making is, when we are going for a first address, then we are making it to a zeros. If we are making all the bits to be 1. So what we have to make it? All the bits has to be 1. So we are making it 32 minus 28. All the bits has to be 1. So all the bits similar as to bit, but this bit has to be all ones. So making us is to a 32. So we will start a block from 32 and we'll go for 47. So first address and the last address of that block. Okay, then it will a number of address to it. We will say is 2 raised to power 32 minus n. That is 20. What means 32 minus 28? 2 raised to power 24. That is 16 addresses we will assign to it. Continuous address starting with 32 and coming with a 47. So this is a example of it. We are having a 16 address here. Then after this is a first thing is how can we calculate it? By making a host bit first zeros also and also 1 also. So in the first address we are making it zeros, and in the last address we are making it 1. But this is another technique to making the first address and last address and address space. What can we do is, we are making that this is a mask. I'm saying that why it's a mask, because all 28 bit is to be ones and all the 4 bit has to be 0. This is my mask. In the classful addressing, what we have 8 ones, 255 000. This is a default mask because we are using class full addressing. But in a classless, we are having 28 bits, so we are making a 28 bit one. So all these 28 bit ones and 4. This is a default mask of it. Okay. Then how to calculate a first address of it? What is a mask? Then it will. What is the address? Make a end of it. End of it 1 1. 110, 110, 110, 001, 111. So we are ending it. So what we have to do is 000, 0, 01, 0, 10, 0 and 11. We are having 1. End it. And then after what the IP is coming, this is my first address. In the last address, what we have to do is, we have to complement it and then after OR it. So in OR case, 0 0 0 0 1 1 1 0 1 1 1 1. So in that we have to, what we getting is the last address. In the first address, what we have to do is ending from the default mask. In the last address, what we have to do is complement the mask, default mask and OR it. In the last address, you will make a complement it and then after make it a number of addresses to it. So this is a shortcut to collect the first address and the last address when you are using a subnet here. Okay, so this is a block of this, and all these are having a mention of this. So we can calculate it by ending an or on word, or also making a z for zeros and words also. Okay, so we have continued this. The first address of the block is normally assigned, because we are not assigning the first address, because the first address to be network address and the last address is the broadcast address. So we are not mentioned. So if we are having a 2 raised to power 4, in the last question we are having 2 raised to power 16 we are having, so minus 2, that is the first address is minus, because this is a network address and the last address is a broadcast address. We are making only 14 computer we can assign the IP that will work convention to it. So the last address network, we will cut it from it, and the first address at the network address we will have that, and the rest will we use as a host into it. Okay. So we are having levels here, but when we are saying that any number, that is an address code, this is the extend code, and this is a subscribe. If we in India, you will use a plus 91 for our exchange that we are using in living into India region. So this is my prefix code and all the host address code. Okay, so we are the left side 2 levels of we are having. The prefix side we are using for network, and the suffix side we are using, the last one is using for the host also. So this is a subnetting we are using here. Okay, so all these are the hierarchies of it. So all these are the examples of it. How can we use customers of it, and then after making a address of it by making a subnetting here. Okay, so these are the group. We can go group 1, group 2, group 3 are having all the available address we are having. So we are having a city, and then after how can, in a city how much houses we can allot, we can use it. Thank you.